All right. As we continue on with like derivatives and finding those derivatives, we're going to realize that while we've done, a really good job finding, functions that look like this or something that looks like this with our power rule, even finding like the derivatives of trig functions, but eventually we're going to come into more complicated problems like 5z minus 8 or e to the w fourth minus 3w squared plus 9. And we're going to have to find the derivatives of those. Now, we can actually do that, and it's with something called the chain rule. So if I look at the two functions, let's say f of z equals square root z, and g of z equals 5z minus 8. I could write a new function, and I could say that it's like f of g of z, which we could rewrite as f of g of z. So we use the chain rule when we have a function inside of another function. That's how we go about using the chain rule. So if I took my f of z and g of z and I use this function, f of g, I'm going to be left with the square root of 5z minus 8. So we're going to find the chain rule, and the chain rule basically works like this. If you're trying to find the derivative of x, you're going to find the derivative of the inside first, or you're going to find the derivative of f, and you're going to find the derivative of just the inside, and you're going to multiply them together. So, and then just like another way, I guess, to state that or to show it is that y equals f of u and u equals g of x. Then the derivative of y is dy over dx, which equals dy over du, and du times dx. So again, I think it's easiest to look at examples of these. So a couple ways you can go about doing it. You can kind of break it apart as you go, or you can find individual derivatives right away. So if I look at the square root of z, I might just go ahead and say, all right, I know that the derivative of this, if I turn this into z to the 1/2, I get 1/2 z to the negative 1/2, which means I need to go 1 over 2 z to the 1/2, or square root z. And then if I looked at my other part, g of z, I said was 5z minus 8. This one's pretty easy. The derivative of this is just 5. So using the chain rule, again, we're using this function right here. So if I was to say, all right, if this is r of z, square root 5z minus 8, what is the derivative of that? So what I'm going to do is I'm going to first find I like to kind of work from the outside in. So I'm going to first focus on this square root function. So again, that's like rewriting it of 1/2. So I'm going to use my power rule. So the first thing it tells me to do is I need to take this and I need to move it out front. So I'm going to take the derivative of f of z here, which is going to equal 1/2 5z minus 8 to the negative 1/2. So it's going to equal 1 over 2 times 5z minus 8. All right, and then I need to keep going, so I'm going to keep going, and now I'm going to focus on just the inside part of my function, which again was 5z minus 8. So we said that, okay, the derivative of 5z minus 8 is just 5. So I'm going to, in each of these steps, multiply by that new derivative. So my final answer is going to give me 5 over 2, 5z minus 8. This was to the 1/2, which I like to write it as a square root sign. So basically, if we wanted to maybe try to put some words to this, this is the derivative of the outside function. Again, derivative of the outside function simplified. This was the derivative of the inside function, derivative of the inside function, and then eventually we had to combine the derivative of the outside and the derivative of the inside. All right, wanted to remind you of the derivatives of trig functions. So again, just have these written down, have these with you as you're working through some of these problems. Gonna keep working with the chain rule. This time gonna add in one of these trig functions. So let's say that we have sine of 3x squared plus x. So again, to look at my original function, what I need to do is I need to basically, in terms, what I'm gonna do is I'm gonna find the derivative of the outside. Then I'm gonna keep the inside the same. And then I'm going to, my third chunk of numbers is going to be, after finding or keeping the inside, then I'm going to find the derivative of the inside. So if we look at our function, again, the derivative of sine is cosine. So as I'm working through this, f derivative of x, so I'm going to get cosine, and I have to leave the middle the same because that is part of my it's part of this function. Trig functions always have like parentheses and stuff inside of their parentheses with them. And then I need to look at the derivative of the inside. So again, if we just pull this out, the derivative of this, if I use the power rule, gives me 6x, and then the derivative of x is just 1. So then I'm going to also have multiplied by 6x plus 1. We usually like to write our coefficients, or just like our numbers, in front. So I would say 6x plus 1 cosine 3x squared plus x. All right, let's take the function 2t to the third plus cosine t to the 50th power. So I'm going to start by using my power rule. So again, as I'm working through this, I'm going to start by using the power rule, which brings everything out front. So I'm going to use 50. I'm going to keep the inside exactly the same. And then 50 minus 1 is 49. And now I have to take the derivative of the inside. So now I'm going to look at the inside and say, all right, 2t to the third, I can use the power rule. So this is going to give me 6t squared. The derivative of cosine is negative sine. So 6t squared, I'm going to use parentheses so I don't forget that it is multiplied by a negative, not subtracted. So now when I look at what I have, again, I'm going to kind of rearrange my my answer so that I have a final answer of 56t squared multiplied by negative sine of t. And then that is also multiplied by 2t to the third plus cosine of t. Let's do a couple more here so we get the hang of it. I'm going to choose, all right, let's say that we have h of w equals e to the w to the fourth power minus 3w squared plus 9. So again, just for starters, I'm going to identify the outside function. We need to be a little bit careful. Is an exponential function, therefore the inside function is its exponent. So what we look for is, again, if this is my outside function right here, is kind of like the whole thing, my inside is going to be my exponent right here. So this looks like I'm going to have to use the power rule. So I'm going to say, all right, this is like 4w to the third minus 6w. And then I still have my original function, e to the w fourth minus 3w squared plus 9. So this one wasn't quite as difficult. It was only really one step there. Very similar type of problem is with logarithms. So if I take the function, let's say g of x. Natural log of x to the negative fourth plus x to the fourth. 1 over, again, just writing my negative exponents down below. Well, actually, again, I have to take the derivative of the inside function and then keep the outside the same. So I'm going to say, all right, the derivative of this is 1 over x to the negative fourth plus x to the fourth multiplied by negative 4x to the negative fifth. Again, just using the power rule here. So that's going to give me, if I simplify, negative 4x to the negative fifth plus 4x to the third. And then this would be x to the negative fourth plus x to the fourth.